Digital terminology. The basic definition of a digital image is the electronic capture of an object using a digital camera or scanner. The image will be mapped as a grid of pixels. Each pixel is assigned a tonal value of black, white, shades of grey or colour. These pixels are represented in binary code. The binary digits or bits for each pixel are stored in a sequence by a computer. The bits are then interpreted to display the image. There are two different types of digital image, raster and vector images. Raster images are made up of grids of pixels, commonly referred to as bitmaps. Common bitmap file types are TIFFs, JPEGs, BMP and GIFs. Vector images are commonly used for graphics and are comprised of paths, which are defined by a start and end point, along with points, curves and angles along the way. A path can be a line, a square, a triangle or a curved shape. These paths can be used to create simple drawings or complex diagrams. They are used for graphics such as logos, as they can be scaled up without pixelation. Resolution is normally expressed as dots per inch, or DPI. Sometimes you see pixels per inch and sometimes centimetres per inch, but most commonly it's DPI. Resolution indicates the number of pixels that are used to make up 1 inch of the image. A JPEG for web use would commonly be 72 dots per inch, and a print quality TIFF would be 300 dots per inch. Resolution should never be used in isolation to indicate good quality. A file could be 300 dots per inch but still only be 1 inch square, so that would still not be printable at an A4 size. The pixel dimension must be considered alongside the dots per inch. Pixel dimension is the horizontal and vertical measurements of an image expressed in pixels. An image that is 8 inches by 10 inches and that has a DPI of 300 will have a pixel dimension of 2400 pixels by 3000 pixels. These figures are arrived at by multiplying 8 by 300 and 10 by 300. This next slide is designed to represent how DPI affects the quality of the image. Both the images are the same size. On the left is a grid which is 18 by 18 pixels with a shape drawn on it. The shape can clearly be seen to be made up of a series of squares and is not a very attractive image. On the right is the same shape, represented in a grid that is 600 by 600 pixels. To fit 600 pixels into the same area as 18, the pixels have been reduced in size, so the shape is now represented as a much smoother, more attractive image. When we use JPEG images, what we get is something called compression. This reduces the size of the image. All compression techniques abbreviate the string of binary code of an uncompressed image to form a form of mathematical shorthand based on complex algorithms. This is an example of an image that is compressed to a compression level of 12, and it's displayed at 200%, so we can see the effect of this. This is the same image compressed more with a compression level of 6. This is the same image again with a compression level of 0. You can see that with this amount of compression, the image has started to degrade quite considerably. Colour space. We've already touched on colour space when we were looking at setting up the cameras. If you remember, we set the colour space in the back of the camera. ICC stands for International Colour Consortium, which was established in 1993 by 8 companies for the purpose of standardising an independent colour management system. The outcome of this cooperation was the development of the ICC Profile Specification. ICC-based colour management workflows are the standard for ensuring reliable colour reproduction from screen to print. Many professional workflows are built around the Adobe RGB 1998 ICC Colour Profile. This profile has been widely adopted because it provides a relatively large and balanced colour gamut that can be easily reproduced on a variety of devices. Every device for capturing and reproducing images has different capabilities for reproducing colour, resulting in colour inconsistencies. Adobe applications introduced the idea of a working colour space that represents the ideal conditions for image reproduction. Effective colour management requires that a colour profile be attached to every image to indicate the colour conditions under which the file was created, known as colour space. The goal is to maintain the visual appearance of the image to the greatest degree possible. This table gives an overview of the units used to make up and describe the size of an image. A bit, binary digit, is the smallest unit of digital information. 8 bits equal 1 byte. We can see from this table that a 17 megabyte image is made up of 1,700 kilobytes. Digital images are often described by the number of bits used to represent each pixel. For example, a 1-bit image is monochrome. An 8-bit image supports 256 colours or grayscales, while 24 or 32-bit supports an even greater range of colours. This final table shows us some of the major file formats and their uses. We shoot images as RAWs, which are digital negatives. They can be processed to any file type that we subsequently need. We process our RAWs to TIFFs. These are uncompressed, widely accepted image files, and archiving of files in TIFF format is a good practice. Other file formats seen in this table are JPEG, which is a compressed file format, and JPEG 2000. This is a file format that compresses images without loss of quality, but it is a reasonably new file format and for that reason should be used with caution.